Mars, our enigmatic neighbor, the Red Planet, has captured humanity's imagination for centuries. Gazing at it from Earth, we wonder, could this distant world have been our twin? What once seemed a frozen, barren desert was, in its distant past, a place of water, rivers, and potentially even oceans. Yes, Mars, despite its present state, was once much warmer and wetter. So, how did this once promising planet lose its oceans? What transformed it from a possible cradle for life to the cold, dry world we see today? The answer lies in a fascinating and complex tale of planetary evolution, atmospheric loss, and cosmic forces. Let's embark on a journey through time, unraveling the mystery of Mars' transformation, of how it lost its oceans and why it became the desert we know now. The first clues of Mars' watery past are evident as soon as we look at the surface. The telltale signs are all around us: ancient riverbeds, vast valleys, and delta-like formations. These geological features, carved by the force of running water, suggest that Mars once hosted rivers and lakes on a massive scale. Orbiting satellites, like NASA's Mars Reconnaissance Orbiter, have revealed startling details. Minerals like clays and salts, which can only form in the presence of liquid water, the Martian landscape. And then there are the more obvious signs, the deep, wide channels that look eerily similar to river systems on Earth. Yet, these features are relics of a bygone era. Mars today is a world without flowing water, its surface barren and cracked, punctuated only by traces of ancient floods and a dry, red expanse. The question, then, becomes not whether Mars had water, but what happened to it. To understand the journey from liquid oceans to barren desert, we must first look back at Mars in its youth, billions of years ago. Early Mars, about 3.5 to 4 billion years ago, may have been a far more hospitable world, with a climate warmer and more stable than it is today. There's strong evidence to suggest that Mars once had a thick, dense atmosphere, possibly made of carbon dioxide and other gases, creating a powerful greenhouse effect. This could have trapped heat from the sun and kept the planet warm enough for liquid water to remain stable on its surface. In fact, scientists believe Mars may have even had oceans, vast, global seas that stretched across its surface. Mars' tilted axis and volcanic activity could have further contributed to its climate stability, creating a planet where seasonal changes were not unlike those we experience here on Earth. In such conditions, liquid water could have flowed freely across the landscape, forming oceans, lakes, and rivers. This might have been a world where rain fell and rivers carved their way through the land, an environment that could have nurtured life. But this golden age was not to last. Over time, conditions began to change, and Mars gradually transitioned from a warm, wet world into the cold, barren desert we see today. What caused this dramatic shift? The key to this transformation lies in the loss of Mars' atmosphere, a slow, destructive process that would forever alter the fate of the planet. Early in Mars' history, its atmosphere was thick and capable of holding warmth, keeping the planet's surface temperatures above freezing and allowing oceans to persist. However, without a strong magnetic field to protect it, Mars was vulnerable to the solar wind, a constant stream of charged particles emitted by the sun. Earth's magnetic field shields us from the solar wind, preventing it from stripping away our atmosphere. But Mars, lacking this protective shield, began to lose its atmospheric gases over time. Solar wind steadily eroded the upper layers of Mars' atmosphere, causing it to thin. With less of an atmosphere to trap heat, temperatures began to drop. The once planet-wide warmth dissipated, and the water that had once flowed in rivers and lakes started to evaporate and escape into space. Without the protection of a thick atmosphere, the surface of Mars cooled, and liquid water could no longer remain stable. Mars volcanic activity likely played a role in its early climate, too. Massive volcanoes like Olympus Mons, the tallest known mountain in the solar system, once erupted with great intensity, releasing carbon dioxide, water vapor, and other gases into the atmosphere. These volcanic eruptions could have helped warm the planet initially, thickening the atmosphere and reinforcing the greenhouse effect. In fact, for a time, Mars may have been able to maintain conditions that were not unlike early Earth, warm, wet, and conducive to the presence of liquid water. But over time, volcanic activity waned. As the volcanoes ceased their eruptions, the gases that had helped maintain the atmosphere began to dissipate. Without ongoing volcanic outgassing, Mars was left with an ever-thinning atmosphere and no longer had the necessary mechanisms to maintain a climate suitable for oceans. But what if Mars isn't entirely devoid of water? Though the surface may be dry and desolate, there is compelling evidence that water still exists below the surface. Researchers have detected signs of frozen water in Mars' polar ice caps, vast reserves of ice locked away in the frigid Martian terrain. Additionally, radar data from orbiting spacecraft suggests the possibility of subsurface lakes of liquid water, buried deep beneath layers of ice and rock. This discovery opens up exciting new possibilities. Could these hidden underground reservoirs harbor microbial life? Or could they provide the resources needed for future human explorers to survive on Mars? The idea that water may still exist in liquid form deep underground reignites hope that, one day, Mars could become more than just a barren desert. It might one day host life once again. Perhaps not on its surface, but within the depths of its hidden caverns. So, could Mars oceans ever return? Could humanity play a part in reversing Mars' dry fate? While the challenges are immense, the concept of terraforming Mars, altering its atmosphere and climate to make it more Earth-like, is a subject of great interest and speculation. Scientists and engineers are exploring methods like introducing greenhouse gases to thicken the atmosphere, warming the planet, and potentially releasing trapped water from beneath the surface. While this idea remains speculative and far off in the future, current missions, like NASA's Perseverance rover and the Mars Sample Return Program, are helping us understand more about Mars' history and its potential for future habitability. As we continue our exploration, perhaps one day humanity will find a way to restore Mars to a more Earth-like state, bringing water back to its surface and offering a glimpse into a new era for our cosmic neighbor. The story of Mars is not one of irreversible loss, but of transformation. The question of how Mars lost its oceans is not only about what was lost, but about how planets evolve and how life itself might adapt in the face of drastic changes. Mars once held the promise of life, just as Earth does today. Perhaps the lesson of Mars is one of resilience, a reminder of how fragile planetary environments can be, and how much we still have to learn about the delicate balance that makes life possible. In the grand scope of the universe, Mars' story is just one chapter, but it's a chapter that speaks to the very heart of human curiosity. By understanding what happened to Mars, we gain insight into the future of Earth, and perhaps even our place in the cosmos. Will we protect our oceans? Or will we learn, too late, that the balance is more fragile than we ever imagined?